The coastal landscape is constantly being reshaped by a variety of physical and chemical processes. These processes act on the rocks and sediments along the coast, leading to the formation of various landforms and the continual change of the shoreline. Mechanical weathering, also known as physical weathering, involves the breakdown of rocks into smaller fragments without any change in their chemical composition. In coastal areas, this can occur through several mechanisms. Freeze-thaw weathering is when water enters cracks in the rock and freezes during cold weather. As the water freezes, it expands, exerting pressure on the rock and causing it to break apart. This process is common in coastal regions where temperatures fluctuate around the freezing point. Salt weathering occurs when sea spray deposits salt in the cracks and pores of rocks. As the water evaporates, salt crystals form and expand, exerting pressure on the rock and causing it to disintegrate. This is particularly prevalent in arid coastal regions and areas with frequent salt spray. Thermal expansion. Rocks expand when heated by the sun and contract when they cool down. Repeated cycles of heating and cooling can cause the rock to fracture and break apart. This process is more effective in coastal areas with significant temperature variations between day and night. Chemical weathering involves the alteration of the chemical composition of rocks, leading to their breakdown. This process is influenced by the presence of water, oxygen, carbon dioxide, and other chemicals. Hydration. Water molecules combine with minerals in the rock, causing them to expand and weaken. This process can lead to the breakdown of rocks like feldspar into clay minerals. Known as hydrolysis, water reacts with minerals in the rock, causing chemical changes. For example, the reaction of water with feldspar can produce clay and soluble salts. Oxidation occurs when oxygen reacts with minerals, particularly those containing iron, to form oxides. This process is similar to rusting and can weaken the rock structure. With carbonation, carbon dioxide in the air dissolves in rainwater to form weak carbonic acid. This acid reacts with minerals in the rock, particularly limestone and chalk, leading to their dissolution. Mass movement refers to the downward movement of rock and soil under the influence of gravity. Coastal areas are particularly susceptible to various forms of mass movement due to the steep slopes and the undercutting action of waves. Rock falls happen when fragments of rock break off from steep cliffs and fall to the base. This can be triggered by mechanical weathering, such as freeze-thaw action. In landslides, large sections of rock and soil slide down a slope. This can occur when the base of a cliff is eroded by waves, making the upper part unstable. Slumping is a type of landslide where a section of the cliff moves downwards along a curved surface, often occurring in areas with softer rock layers like clay. Soil creep is the slow, gradual movement of soil down a slope, influenced by gravity and the expansion and contraction of soil particles. Erosion involves the removal and transport of rock and soil by natural agents like water, wind, and ice. Coastal erosion is primarily driven by the action of waves and currents. Hydraulic action is the force of waves hitting the coast, compresses air in cracks and joints in the rocks. The pressure exerted by the trapped air can cause the rock to break apart. Abrasion happens when waves carrying sand, pebbles, and larger rocks scour the coastline, wearing away the rock surface like sandpaper. Attrition is rock fragments carried by waves colliding with each other, breaking into smaller, smoother pieces. Solution, or corrosion occurs when seawater, which is slightly acidic, dissolves soluble minerals in the rock, particularly affecting limestone and chalk. Waves are the primary agents of coastal erosion, transport, and deposition. They are generated by the wind blowing over the surface of the sea. Destructive waves are high-energy waves with a strong backwash that erodes the coast. They are more common during storms and high tides. Constructive waves are lower-energy waves with a strong swash that deposits material on the shore, building up beaches. Wave refraction happens as waves approach the coast. They bend and change direction due to the varying depth of the sea floor. This concentrates wave energy on headlands and disperses it in bays, leading to differential erosion. Longshore drift is when waves hitting the shore at an angle transport sediment along the coastline in a zigzag pattern. This process contributes to the formation of features like spits and bars. The coastal landscape is shaped by a dynamic interplay of mechanical and chemical weathering, mass movement, erosion, and the action of waves. These processes work together to continuously reshape the coastline, creating a variety of landforms and influencing the natural and human activities in coastal areas. Understanding these processes is essential for managing and protecting coastal environments from the impacts of natural forces and human activities.